And what is an acceleration? Also, um, what is the displacement or distance is? Displacement is, right? Now, in this section, we also learned a set of equations. The equations are very important because we have discussed several past paper questions, and we saw that how these linear motion equations have been used. So I'll also going to add motion equations. Right. Okay. So in this first lesson, we have studied that, like, what is meant by a speed. So speed is a something we call speed measures about how faster we move. So a speed is we call a rate of change of distance, rate of change of distance. These are simple stuff. Okay, I'm starting from simple stuff. And if they ask what is the unit of speed, is meters per second, meters per second, or else we can use kilometers per hour, kilometers per hour. Right. If you want to change between meters per second and kilometers per hour, then that is the easy way to do that too. Right. If you want to do that, let me show you this easy way to do it. So if you want to convert meters per second into kilometers per hour, just multiply by 3.6. Okay, like let's say you have 10 meters per second, and then you multiply it by 10 meters per second, and then you multiplied it by 3.6, so that you get 36 kilometers per hour. Okay, so that just multiply by 3.6. If you want to go from kilometers per hour to meters per second, all you need to do is divide it by 3.6. Right, so that's a simple conversion between these two. Right, the next thing is the speed has the equation also. So the speed equation is like speed equals distance divided by time. Okay, and one more important thing we learn about speed is that speed is a scalar quantity. A scalar quantity, right? Scalar quantity in the sense speed doesn't have a direction. The speed has only a value. So when some quantity has only a value, we call it a scalar. Right? Then the velocity. Velocity is the vector version of the speed, which means velocities have a direction. So the velocity is a vector. Vector in the sense it has a both magnitude and direction. Both magnitude and direction. But scalars have only a magnitude. Magnitude means a value. And velocity is we call rate of change of displacement. Displacement. In another word, how much of displacement change with a given time. Rate of change of displacement. And velocity, of course, has the same unit. So same as meters per second, same as kilometers per hour. It's the same unit either way. And so velocity and speeds are usually related physical quantities because they actually represents the same thing with a small difference. The difference is vector and scalar. One has a direction, the other one doesn't have a direction. Otherwise, they both measures about how much of speed we travel. Right. The next thing, they have an equation 2. So that velocity equals displacement over time. Displacement over time. So this is the equation for the velocity. Right. Now, the next thing is the acceleration. So accelerations is we call rate of change of velocity. Rate of change of velocity. Right. Acceleration is unit is meters per square second. ms minus 2 meters per square second. And acceleration is a vector, which means it has a direction and a magnitude both. Magnitude and direction both. Right. So that's an acceleration. And acceleration, when it becomes negative, which means we can have both positive accelerations, both negative accelerations. So when the acceleration becomes negative, we call it is a deceleration. Deceleration. Right. And acceleration, we have equation. We have studied an acceleration equation. A equals v minus u over t. So acceleration equals v minus u over t. So what is v? V is the final velocity. Final velocity. U is initial velocity and t is a time. Right. So in the class, we do calculation related to them. So, but this is the point you can remember the equation at the end. So, final velocity minus initial velocity divided by the time, which is we call acceleration. Right. So, accelerations, we can have two types of acceleration. It can be a deceleration or it can be an acceleration. So, a deceleration means it is a decreasing velocity. If you decreases the velocity, it's a deceleration. So this is a decrease of velocity. Decrease of velocity. Like this. Okay. Now, that's about acceleration and deceleration. So we have studied now three factors: speed, velocity, acceleration. Now, the next thing is distance. Right? The distance is about how much we move. So distance is a scalar, which means distance doesn't have any direction. A scalar, which means distance has only a magnitude. And the SI unit of distance is meters. Meters. Right. So then the other thing is the displacement. Displacement means, because we don't have much thing to learn about distance, but displacement. Displacement is we call the shortest distance between two points. Shortest distance between two points. Now, if it is a shortest distance, it obviously has a direction, because let's say for an example, we have 2 points, point A, point B. We can go from A to B in many different ways, like this. These are all we call distances. But there's only one way we can go from A to B. So that is we call uh, displacement. So when we go from A to B directly, which is we call the shortest distance that this can travel, the shortest distance this can travel. So displacement is unlike the distance, it has a direction. So that distance, displacement is a vector, distance is a scalar. So that is the main difference between the distance and the displacement. Right. Okay. So I hope that you're okay up to this point, what we discussed about the motion, physical quantities which are related to the motion. So finally, we are going to have two equations here uh, that we are going to discuss. Right. Okay. Right. Now the two equations we have studied at the last minute. This is the one. This is the part I want to tell you. The two equations we have studied is v squared equal u squared plus 2as and v equals u plus at. One equation is v squared equal u squared plus 2as, and the other equation is v equals u plus at. So the two equations related to five quantities: v, final velocity; u, initial velocity; a, acceleration or deceleration; t, time; s, displacement. Final velocity v, initial velocity u, acceleration or deceleration a, displacement s, time is t. Right. Now, these are the five quantities related to these two equations. Now, the important thing is you will see both of these in your constant list. So in your exam paper, you get a equation list. In that equation list, you have these two equations, so that remember them, but you can also refer in your paper. Okay, right. So that is all we have for today's session, that I have completed you with the motion equations part today. In the tomorrow session, I'm going to discuss about motion graphs, which is velocity time graphs and the displacement time graphs, and little bit of acceleration time graphs as well. Right. If you have any doubts or problems, now you can send me through the chat. And also you can copy down my note like I did in your A4 paper and collect them so that you can have bundle of short notes. You can actually make them much shorter in the next time. If you have any doubts or any problems or any things that you need to discuss in the next few sessions, you can send me. Yes, Shavin, there was actually a problem with the writing on the screen. Yes, I'm going to share the video. So everyone will get the video. Every day I'm going to do that. So